What is it? What is this sequence? What is this series? Should I say? What would be the first term? Yeah, it'd be 1. What's the second term? 2 squared. Yeah. So I'm putting in 1 for I, then 2 for I, then 3 for I. So it's 1, 4, 9, or 1 squared plus 2 squared plus 3 squared is equal to this. When they add up, do they equal this? All the way up to n squared. Yeah, does that make sense? So that this can be written like this as well. That's okay. You can rewrite it. If you don't like sigma, you can write it as a series adding up. But of course, we love sigma, so. Right. Yeah. So let's test for the base case for n equal to 1. So on the left-hand side of this, we have, well, we already did it over here. It's 1, isn't it? 1 squared. Does that equal on the right-hand side 1 times 1 plus 1 times 2 times 1 plus 1 all over 6. So I'm using this formula here on the right-hand side. 2 times 3 is 6 times 1 is 6, which is 6 over 6, which is 1. We happy with that? So left-hand side equals right-hand side. Sweet. All right, let's move on to the assumptives. Assume. Remember tapas. So we're going to assume for n equal to k. Okay, so that means this series, I'll stick to blue maybe. This series I is equal to 1. We're assuming it works for some number k. That's not an n, it's k. 2k plus 1 over 6. Very good. We have assumed that. Don't really need to think about that. But we do need to think about prove for n equal to k plus 1. So that means everywhere over here I have written k, I'm going to write k plus 1. K plus 1. I is equal to 1. I squared. Oh, this is going to be a bit of a mess. K plus 1 times k plus 1 plus 1. I know you can simplify this, but it might be nicer to have it written like this first, just in case we need to look at the exact substitution later on. So everywhere there was a k, I put k plus 1. Now, this might be actually nicer to deal with if it was written like this. Perhaps you prefer that. You can, of course, write that this would be 1 squared plus 2 squared plus 3 squared all the way up to n squared equals that, which might be easier to sub into than this. This is a bit maybe abstract, or I can't remember what this looks like, so let's just write it out longhand. 1 squared, 2 squared, 3 squared, all the way up to k squared plus k plus 1 squared is equal to that. Are we happy with that? So that will help us when we go to sub in the assumptive step. I think we can pretty much do the p straight away, can't we? Or the p, the a, the assumptive step. If you just... so I can see it here. This should be k, not n, of course. We did k. We can see that this can be replaced with this, can't it? So I have that right here. That's right there, this bit. And it can be replaced with that. And that's my assumptive step. So can be replaced k plus 1, 2k plus 1 over 6 plus k plus 1 squared. All right? Load of ways to do it. So now it's just an algebra question. Can I get this left-hand side to look like this right-hand side? Now I'm going to work out the right-hand side now, just because I might get it looking like this, or I might get it looking like this simplified or expanded a little bit. Both would be okay. So I'm just I'm not going to multiply it all out. I'm just going to change this to k plus 2, yeah? And this is going to be, is it 2k plus 3? Am I right in saying that? Yeah. Thank you. Okay, so it might look like this or like this. I'm not sure which one I'm going to get in, but I'm going to try and get that left-hand side to work into that position. All right. I see a fraction, so I'm just gonna use common denominator. 6. I'm gonna write this over. So this is gonna be 6k plus 1 squared over 6. Add the fractions. Okay, so here I have k plus 1, 2k plus 1, plus 6 times k plus 1 squared, and now that's all over 6. Are we happy with that?
If you wanted, after your assumptive step, at like k times k plus 1 times 2k plus 1 over 6, could you just write that as k squared?
Oh, you want to multiply it out? Yeah, you could.
No,
Oh.
just because it doesn't it tell you that that is equal to k squared. That's the whole.
This thing equals 1 squared plus 2 squared plus 3 squared all the way up to k squared. Okay. Listen, it's not looking like that. Also, I can see that these are 3 things multiplied by, and there's no like adding between them. So this one has like a break here. So maybe if I multiply out or do some sort of factorizing, it would help me. What would I like to factor out of everything in front? 6? No. K plus 1. K plus 1 is the first thing I want outside everything, yeah? See, that's the first term on the outside here. Maybe I can make it my first term on the outside here. Do both terms have a k plus 1 to factor out? Yes. So I'm going to take out a k plus 1. That's factored out. And what's left behind? Well, from this first thing, I've got k times 2k plus 1, yeah? And I've got plus 6 times k plus 1, yeah? Are we happy with what I've done there? I've factored out k plus 1 out of both of these. Let's come out here. And it's still all over 6. Right. If I can get a k plus 2 and a 2k plus 3, then we're done. Can I take out a k plus 2? Not currently. I've got k plus 1s and I've got... Maybe if I multiplied this out, it will make it quadratic. Because I'm going to get k squareds and k's and stuff. So let's multiply this out. I still have my k plus 1 on the outside. And I'm going to just multiply this out and tidy it up and see what happens. So I get 2k squared plus k plus 6k plus 6. This is 7k, isn't it? Yeah. All right, I'll write 7k plus 6. And that's all over 6. Can I factorize this? 2k and k anyway. You're thinking 6 and 1. I'm thinking 3 and 2 because I look at what it was going to make.
Oh, yeah.
Will it make it if I do 3 and 2? Yeah, plus and plus.
Oh, yeah.
And k plus 1 is still here. That's all over 6. And it's done. And then your tapas, your S is your statement, which I'm not going to write. So it's true for n equal to 1, true for n equal implied for n equal to k, and so on. Tapas, yes?
Do you have to do it on one side, or can you go like, set it?
Yeah, pick the left side, yeah.
I mean, like,
Yeah.
can you keep both sides together?
You're better off picking one side and sticking with it. Okay, that's me done. I have some questions up here, which I imagine you're going to get done in class.